quite common not only in military, but also the clinicians who work almost 8 hours to 12 hours for emergency people. They have lack of sleep. And therefore, our research, as mentioned by US Air Force and Department of Defense, for the first time suggests that sleep deprivation impairs the blood-brain barrier, and that is one of the regions that brain pathology may develop. I will try to show you using some experimental data. This is Dr. Fong from Zhejiang, Dr. Lin from Beijing, Professor Wang from Beijing, Lars Wiklund from Sweden, and this is me, this is my wife. We have no relevant disclosure to make it. The conclusions are ours, not by the agencies for which we are working. As I told you before, we believe that blood-brain barrier is the gateway of all neurological diseases. Sleep deprivation is very common. Our military personnel everywhere in the whole world. And we feel that sleep deprivation induces blood-brain barrier and also blood CSF barrier disruption, and breakdown of these two barriers induce cellular damage in the brain. One cartoon show you that sleep disorders accumulates amyloid beta and also mitochondrial dysfunction and oxidative stress. They are senile plaques and formation of pathological things and leading to brain atrophy. Even one night of sleep deprivation enhances amyloid deposit in the brain. This is well known and published in the literature. And they are very similar combination between Alzheimer disease and Parkinson disease, as the previous speaker has shown you many facts. And this could be one cartoon showing the sleep deprivation and potential risk. Overlapping functions, tau, Alzheimer disease, alpha-synuclein, these are all overlapping and can produce both Alzheimer and Parkinson disease, like neurodegenerative diseases. This shows that sleep deprivation can activate many of the factors in the body, leading to cumulative disease formation in the brain as well. We have shown for the first time that sleep deprivation opens the blood-brain barrier, as published by several publications. So, since our military has severe deficit of sleep and they are also prone to traumatic brain injury, what will happen if the two things are combined? This study shows that the sleep deprivation can affect the mental functions like very similar, like alcohol-induced impairment of the brain function. This is an example in US military how they can provide their time during war or peace. So sleep is really a deficit in this population. I am showing you some example of blood-brain barrier leakage in an AUP infusion, and treatment can reduce the leakage of blood-brain barrier. Also, it affects glial populations, GFAP activation, and reduction by different drug treatments. Likewise, here the cellular damage here in the brain, and they are reduced by different treatments. can be seen similarly at electron microscopy, severe damage, and they are partially restored. When we use the same drug called cerebrolysine, which is a mixture of different growth factors, and you can see that when we level nanowired cerebrolysine, the results are much better than the untreated group. Here are examples that what will happen if we use two different methods of drug delivery. One is nanowired, one is PLGA level. There is difference. What we can see that nanowired delivery of cerebrolysine is much better than PLG level cerebrolysine. And the value that I can show you, they are reduced, but there are differences between nanowired cerebrolysine here and PLGA level cerebrolysine. You can see the values are different. Nanowired is more significant. This is an example of temporal cortex pathology. Here we have given drug treatment in nanowired cerebrolysine, and here is the control value. They are different treatment. Nanowired cerebrolysine potentiate the effect of S422 antibodies for neuroprotection in Alzheimer disease. This is also one of the results by Innovation Award for more than 15% innovation. As you can see that when we have given co-administration of nanowired alpha melanocyte stimulating hormone and cerebrolysine, that induces closed head injury following sleep deprivation. So this is sleep deprivation. This is sleep deprivation of with CHI, closed head injury, and this is sleep deprivation CHI with nanowired mesenchymal stem cells. As you can see that neuroprotection can be evident clearly in rats. These are the examples of different time period of sleep deprivation, 24 hours, 48 hours and 72 hours. They are gradually increased. Number of injured cells in cerebral cortex. CHI, closed head injury, they are also time dependent, 24 hours, 48 hours, 72 hours. When they combine, it is significantly enhanced. When we treat it with mesenchymal stem cells, they are reduced. But when we have infused nanowired mesenchymal stem cells, it is significantly different than this group. Measure some biochemical parameters, amyloid beta peptide, p-tau, serotonin, blood barrier disruption, and blood CSF barrier disruption. Sleep deprivation 48 hours, the value is significantly increased and controlled, all cases. Then we have given nanowired cerebrolysine, the value is significantly decreased, and then combination of different treatment using nanowire, you can see the values are significantly decreased than the untreated group. Then we have used sleep deprivation with amyloid beta peptide infusion. This is the control level, no treatment. When we treated, the cells look better than the untreated group. The same happens at electron microscopy. There are damage as well here, but still the picture looks a bit compact around the cells. And here is the case. The untreated sleep deprivation 48 hours, and after that treatment, some cells were significantly protected. Same example in brain stem. Here with the drug treatment, and here is the untreated group. Amyloid beta peptide is significantly increased after sleep deprivation and drug treatment significantly reduced. Microglial activation is significantly enhanced after sleep deprivation, that was attenuated significantly after different kinds of drug treatments using nanodelivery. This is the electron microscopy of one axon here, and here the axons are better protected. I tell you the same thing. Not all drugs are better. We have to find good drugs to give them the nano delivery so that they are much better neuroprotective than other drugs when they are labeled with nanowires. I told you the basic mechanism, why they are more effective. Dr. Shelley, who is Nobel Prize winner of physiology and medicine, has small molecules of fragments, and now we are testing those things. Let us see how we come to show the results probably in the next meeting. So we have planned to provide nanomedicine with different comorbidity factors that influence diseases and see that what we can do for clinical therapy. I stop here from Uppsala University. Thank you very much for listening.
You're wonderful. You save everyone 2 minutes. I overused, so you save. We balance. Okay, questions, comment. Good, take a rest. Thank you very much.
Thank you very much.
Yeah. Our next speaker is Dr. Wang Juanling.